All right, guys, so we have started by talking about how to solve equations, specifically linear equations. And we're going to now transition into talking about some applications of percents. Those equation solving ideas will certainly arise. One of the other techniques that you're going to see us use is that of a proportion. And so let's go ahead, head over here and see what we can see. So we're going to talk about applications with percent, but really probably the best place to start would be just to ask, what is a percent? And so, first and foremost, a percent is a ratio of a number to 100. And remember, a ratio is just a word for fraction, okay? It's just another word for fraction. And so it's a comparison of a number to 100. So when you see a percent, that means a over 100. 5%, for example, would mean 5 over 100. And then, of course, you can reduce that. You can write that as a decimal. But in terms of meaning, that's what 5% means. Okay? Okay. So how do we convert between percent notation and decimal notation? Well, we kind of already hinted at it, right? When I said 5% means 5 100ths, well, that actually means 5 divided by 100. And there it is, right? Dividing by 100. Now, we know from fraction arithmetic that dividing by 100 is the same as multiplying by 1/100th. But however you want to consider it, 5 divided by 100 is 0.05. I'm sure you've heard the idea that converting between percent and decimal means moving the decimal left 2 places. That's what the dividing by 100 does, right? There's the ones place, the tens place, the hundreds place. 2 zeros here. So we're moving left 2 decimal places. And so we might think of it that way. Move the decimal point left 2 places. Now you might say, well, hey, wait a second, 5%, I don't see a decimal point. Well, just keep in mind that we don't usually write a decimal point when we're talking about whole numbers, but it's understood that it's after the ones digit, right? So moving it 2 places, whoops, 1, 2, and then understanding that if there's an empty space there, we're going to fill it with a 0, okay? So 5% is 0.05, okay? So here's some. Convert between percent notation to decimal notation. So of all Americans, 55% do volunteer work. Well, 55%. The decimal is understood to be right there. If you want to add it, we're going to divide by 100, which moves left 2 decimal places. And so we have 0.55. Okay? How about 0.8%? Well, 0.8%, same thing. I'm going to move the decimal 1, sorry guys. I'm going to move it 1, 2 places. And again, that second place that I move it, I'm going to add a placeholder there, 0. So 0.08, okay? You might also wonder, well, can't I just write 0.08? Because when you move this decimal, 0.008. When I move this decimal, don't I just have 0.008? And yeah, you do have 0.008, but I like to write a 0 in the ones place, just as a matter of grammar. Would it be incorrect if you wrote 0.008? No, but it's just good grammar to include your 0 in your ones place. Let's do one more for good measure. What if we had 1.7%? Well, again, we're going to move this 2 places. And so we have 0.017. And again, I can put a 0 in my ones place. Oh, sure, let's do one more. Why not? Why do 3 when you can do 4? I guess that's bad logic. We just keep going indefinitely with that. All right. How about 1.25%? Well, actually, you know what? I'm going to change this. I'm sorry. I'm going to do 125%. Let's do that. And so where's the decimal? Well, it's after this 5. We move it left 2 places. 1, 2. 1.25. And we should expect to get something larger than 1 because our percent is larger than a whole, or 100%. Okay? All right. Onward. What about the other way? What if we have decimal notation and we want to convert to percent notation? Well, to go from percent to decimal, we divide it by 100. So if we go the other way, we multiply by 100, right? If I had that 0.05 and I want to turn it into a percent, then I'm going to multiply by 100. And that will move this decimal 2 places. Right, so 0.05 is equivalent to 5%. Okay. Try a couple more. USDA defines food security as access to enough nutritious food for a healthy life. In 2010, in other words, meaning you don't have to eat from a convenience store. And I'm only half joking. Some people, that's just all there is in their neighborhood. And that's a travesty. In 2010, approximately 0.057 of US households had very low food security. So I'm going to take this 0.057 and convert it to a percent. In other words, I'm going to multiply by 100. So I move that decimal to the right, 1, 2, we get 5.7%. Okay. How about 1.08? Well, 1.08. I'm going to multiply by 100, which moves this decimal 2 places to the right. So we get 108%. And then 5/6. Gosh, that's a fraction. Well, that's okay. Can't we write fractions as decimals? Absolutely. So watch what happens here. Uh-oh, come back. I'm going to take and first convert it to a decimal. And so to do that, I'm going to go back to yesteryear, do some good old long division. How about that? So 6 goes in to 50 8 times, which is 48. Subtract, have a 0, bring it down. 6 goes into 20 3 times. 3 times 6 is 18. Subtract, I get 2, bring down another 0. 6 goes into 20 3 times. Do you see what's going to happen? Right? These 3's are just going to repeat because I'm going to keep getting a remainder of 2. And so bringing down another 0. So I'm going to continue to have 6 into 20, 6 into 20, 6 into 20, indefinitely. So 5/6 is really 0.83 repeating. Well, now I can go in and write this as a decimal, which I've done, and then convert my decimal to a percent. So if I move that decimal 2 places, 1, 2, well, let's think about what's going on here. I'm going to rewrite this. You get the point. Dot, dot, dot. They keep going. So if I move this over 2 places, 1, 2, I still have infinitely many 3's going, right? And so this is 83.3 bar percent. All right? Or you might recognize 0.3 bar as 1/3. Either way. All right. So how do we put these into use? How do we actually solve problems? Well, some of this we can just translate and wind up with an equation to solve. Of translates into multiplication. What number? That's my variable. What percent? That's something over 100. Is, that means equals. Okay? And maybe instead of X for my what percent, I'll use a P, like I mentioned on the bottom here, P for percent. Okay? And so if we have some contextualized problem, something you might actually encounter, I mean, let's be honest, no one's going to walk up to you and say, hey, 5/6, what is that as a percent? Go. I don't know of anybody that has, except for maybe a student in this class or another math class, but in actuality, that's not really something you'd encounter, right? You might encounter something else, which we'll get to shortly. So really, there's 2 general methods, and I'll show both of them to you. There's what I call direct translation, which really amounts to solving an equation, or a proportion. Okay, and so the proportion is this part over whole equals percent over 100. Okay. All right, so let's try these. What percent of 125 is 30? Well, what percent? Didn't we just get done saying that what percent can be translated as P over 100? And of can be translated as times. And is can be translated as equals. So I have this nice equation. Right, this reduces, right? 25 goes into 125 and 100. So I wind up with 5/4 P equals 30. Okay? Well, we know how to solve this, right? You multiply both sides by the reciprocal. Okay, you multiply both sides by the reciprocal. So 4/5 times 5/4 P equals 4/5 times 30. So P equals, 5 goes into 30 6 times, 24. So what's our answer? 24%. Okay. This would be an example of what I'm calling direct translation, right? I literally took this sentence and I translated it into our mathematical language. And in translating, I wind up with an equation, okay? Well, for B, let's try the other method, the proportion method. And so one of the ways I like to think of these proportions is to recognize that I have a part, which is denoted by is. I've got a whole, which is denoted by of. And then I've got a percent over 100. Again, percent over 100, that's part over whole. Is over of is part over whole. So we have part over whole equals part over whole. We want our parts in the numerators and our wholes in the denominators. Well, now let's fill this in. If I read it, 54 is 24%. So there's my percent over 100. And then of what number? My of is what I'm looking for. And then hopefully you remember that, when you solve a proportion, you solve it by cross multiplying. So 24x equals, and then 54 times 100 is 5,400. Okay? So I cross multiplied, right? When I say cross multiply, I'm really, cross multiplying over the denominator, okay? And then we're going to divide both sides by 24. And so 5,400 divided by 24 is 225. Okay? So 54 is 24% of 225. All right? How about C? Let's try this proportion again. Is over of equals percent over 100. Well, what's my is? What's 70? What's my of? What percent of 70? Equals, and I'm looking for the percent, right? What percent? So P over 100. Oh, well, gosh, 70 over 70 is 1. So P, you can cross multiply if you want, but what does P have to be in order to divide by 100 and get 1? Well, it's got to be 100 itself. Well, that makes sense, right? What percentage of $70 do I have if I've actually got $70? I've got 100%, right? Okay. So let's put this into practice. Okay, see some problems that might be more, common context. So to obtain her bachelor's degree in journalism, Addie must complete 125 credit hours of instruction. If 20% of Addie's credit hours remain to be completed, how many credits does she still need to take? Okay. So she still needs to take 20%. Well, 20% of what? Well, 20% of however many hours she has to complete, which happens to be 125. So I'm going to translate this into, I'm going to rewrite this as a simple expression. What number is 20% of 125? That's what we're really asking. And so I've got this 20 over 100. And then 125 is my whole, right? That represents the entirety, or 100% of the credit hours she must complete. So that goes in my denominator, right? 125 credits corresponds to 100%. It's also the of part. And so I'm looking for that numerator. So we go ahead and cross multiply. Of course, you could reduce first if you wanted, right? So we get 2,500, divide both sides by 100. X equals, and then don't forget our units here. What are we talking about? We're talking about credits. So she needs 25 credits. Okay. Or credit hours. Selena left a $12.76 tip for a meal that cost $58. What percent of the cost of the meal was the tip? What was the total cost of the meal, including the tip? Okay. Well, the meal was $58. And so the cost of the meal, all right, $12.76 is some percentage of what the meal costs. Guess I'll put a dollar sign over here too. Okay. And so if I'm using the proportion, 1276 over 58 equals percent over 100. Cross multiply. Divide both sides by 58. And so P is going to equal, let's see, 22. So she left a 22% tip. Of course, the total cost would be the $58 plus the $12.76. So $70.76. Okay. All right. How about this one? In a medical study, it was determined that if 800 people kiss someone else who has a cold, only 56 will actually catch the cold. So how much do you like this person? How bad do you want to kiss them? What percent is this? Which really, if we're extending this, we could ask, what probability would we have of catching a cold? So, again, 56 is what percent of 800? And so is over of 56 over 800 equals P over 100. Cross multiply. And then 5,600, right? You should be able to do this in your head because 8 goes into 56. So 7%. There we go. So those are percents. I mentioned there's two ways to solve percent problems. There's the direct translation and the proportion. You can probably guess which one I prefer. I clearly use the proportion method much more. And the reason is that I like to think proportionally and making sure that we have, ratio equals ratio, part and whole, right? There's a whole that we could represent as a percent, 100%, and there's a whole of whatever quantity we're talking about, whether it's the credit hours or some dollar amount. I don't know. You want to really be adept at cross multiplying and going through that process of solving a proportion, because if you are, then once you're set up, once you get your proportion set up, you're good to go. Okay. Last thing to keep in mind, remember your units And remember your percent symbol. If you're finding a percent, right, then we need to actually report our solution or our answer as a percent. So it'll come with practice, obviously, and we're gonna do some practice and get you going. So that's it.